So let's start with another tutorial, which is discriminator versus generative AI. So in simple words, a discriminative model makes predictions on unseen data based on conditional probability and can be used either for classification or regression problem statements. On the other hand, a generative model focuses on the distribution of a dataset to return a probability for a given example. Generative AI models can understand the context of the input data, making them ideal for applications such as chatbots, automated content creation, and text-to-speech systems. With the development of large language models such as Cohere's NLP platform, generative AI has become more powerful, producing human-like text and enabling a wide range of possibilities. Cohere is one of the leading companies in generative AI, with its powerful language model capable of performing various natural language processing tasks, including text summarization, question answering, and language translation. Discriminative AI, on the other hand, is better suited for classification tasks such as image or speech recognition. Generative AI and discriminative AI are two different approaches to machine learning, and they have unique applications. Discriminative AI focuses on finding a decision boundary that separates input data into different classes. For example, an image classification discriminative model would attempt to learn the boundary between different types of images, such as cats and dogs. In contrast, generative AI focuses on modeling the joint probability distribution of the input data and labels, which can be used to generate new data that is similar to the original data. Machine learning models are generally of two categories and may belong to either the generative or discriminative model categories. So let's first try to understand the difference between these two categories of models. What does it mean for a model to be discriminative or generative? Generative models are often used to predict what occurs next in a sequence. Some salient points about generative AI. Generative AI requires less training samples, models the distribution of individual classes, provides a model of how the data is actually generated, learn the underlying structure of the data, have discriminative properties, make some kind of structure assumptions on your model. Decision boundary, where one model becomes more likely, obtain, open, or outperform discriminative models or smaller data sets because their generative assumptions place some structure on your model that prevent overfitting. Natural use of unlabeled data takes all data into consideration, which would result in slower processing as a disadvantage. Generally function for outlier detection, typically specified as probabilistic graphical model, which offers rich representation of the independent relations in the dataset. More straightforward to detect distribution changes and update a generative model. Takes the joint probability and predicts the most possible known label. Typically more flexible in expressing dependencies in complex learning tasks. A flexible framework that could easily cooperate with other needs of the application. So results in higher asymptotic errors faster. Training methods usually require multiple numerical optimization techniques. Will need the combination of multiple subtasks for solving complex and real-world problems. And discriminative AI learned the hard or soft boundary between classes, providing classification splits, probabilistic or non-probabilistic manner, allow you to classify points without providing a model of how the points are actually generated, don't have generative properties, make few assumptions of the model structure, less tied to a particular structure, better performance with lots of example data, higher accuracy, which mostly leads to better learning results. Discriminative models can yield superior performance in part because they have fewer variables to compute, saves calculation resource, can outperform generative AI if assumptions are not satisfied. Real world is messy and assumptions are rarely perfectly satisfied. Do not generally function for outlier detection. Do not offer such clear representation of relations between features and classes in the dataset. Yields representations of boundaries more than generative. Do not allow one to generate samples from the joint distribution of observed and target variables. Generates lower asymptotic errors. Generative models are often used to predict what occurs next in a sequence, whereas discriminative models are used for either classification or regression, and they return a prediction based on the conditional probability. Let's explore the differences between generative and discriminative models in more detail so that we can better understand what separates the two types of models and when each type should be used. Generative versus discriminative models. There are a variety of ways to categorize a machine learning model. A model can be classified as belonging to different categories like generative model, discriminative model, parametric models, and non-parametric models, tree-based models, and non-tree-based models. Generative models are those that center on the distribution of the classes within the dataset. The machine learning algorithm typically models the distribution of the data points. Generative models rarely or rely on finding joint probability, creating points where a given input feature and a desired output level exist concurrently. Generative models are typically deployed to estimate probabilities and likelihood, modeling data points and discriminating between classes based on these probabilities. Because the model learns the probability distribution for the dataset, it can reference this probability distribution to generate new data instances. Generative models often rely on Bayes' theorem to find joint probability finding. Essentially, generative models model how the data was generated. Answer the following question: what's the likelihood that this class or another class generated this data point or instance? Examples of generative machine learning models include linear discriminant analysis, that is LDA, hidden Markov models, and Bayesian networks like naive Bayes. Discriminative models. While generative models learn about the distribution of the dataset, discriminative models learn about the boundary between classes and within dataset. With discriminative models, our goal is to identify the decision boundary between classes to apply reliable class labels to data instances. Discriminative models separate the classes in the dataset by using conditional probability, not making any assumptions about individual data points. Discriminative models set out to answer the following question: what side of decision boundary is the instance found in? Examples of discriminative models in machine learning include support vector machines, logistic regression, decision trees, and random forests. Thank you.